So my first thought on how to solve this one would be, why don't we just complete the square, make a quick little graph of this, and then we can solve everything from there real nice and easily. So let's give that a try. So y equals x squared minus 5x, and again we'll just re-represent our equation that way, and then stop and think, okay, let's do a complete the square here. And negative 5 divided by 2, oh, that's not great. We end up with a decimal, 2.5. And then what we can do is we can square that, and we end up with plus 6.25. And we're adding 6.25 to the equation, so we'll subtract 6.25, and so then this would be x minus 2.5 squared minus, and add those two together, 30.25. Now, you're probably looking at that and thinking that is kind of ugly, in that we have all the information we need, but going into decimal forms and stuff like that, is there another way to do it? Indeed there is. So let's set that aside. It is enough information that we could do a quick sketch from there and solve everything. So it is a legitimate way to do it. Let's just look at an alternative for when you run into weird numbers like that. Maybe there's a better way. So first of all, let's consider each part individually. X-intercepts. What does an x-intercept mean? It means when the y is 0. So let's set the y equals 0. So we have x squared minus 5x minus 24 equals y, or 0. Now, how do we solve for x to make that true? Well, let's give factoring a try. So x and x, and what are two numbers? Multiply to negative 24 and add to negative 5. Well, we could do negative 8 and positive 3. And so what does that tell us? Well, in order for that to come out to be 0, either the first term has to be 0, which if x was 8 would make that 0, or the second term would have to be 0, which would be minus 3. And so we have our x-intercepts. That's not a bad way to do it. And so from there, we can kind of work out a few other things. What about the extrema? And so I'm just going to draw a quick little sketch here, x and y. And we know that one of the x-intercepts happens way out here at 8 and the other at negative 3. So we know that this kind of does that. And so what's this line of symmetry there? Well, that would be the average between the two of them. So if we ended up, so let's do the symmetry, since we're going to have to solve that anyways. So the symmetry is going to be, let's see, positive 8 minus 3 over 2. So we add those two, divided by 2. 8 minus 3 is 5, divided by 2 is 2.5. So we know that x is equal to 2.5 at that line of symmetry. Now, that if we decide to look back, that kind of confirms with what we had there. So now from the extrema point of view, we definitely know that it's a minimum. What exactly, and we know that the x value is 2.5. What's the y value? Well, if we go back to our original equation, y equals x squared plus 5x, or minus 5x minus 24, but we plug in 2.5 squared minus 5 times 2.5 minus 24. And so what we're saying is, what is the y value when the x value is 2.5? And that will give us our minimum, our extrema there. So we plug that into our calculator there, and we come up with negative 30.25. 0.25. And yeah, that goes along well with our other way of doing it. And so we can mark this as a minimum. Okay, so we've got our line of symmetry, we've got our extrema. Right, domain and range. So the domain, like regular parabolas worldwide, it goes forever to the left, it goes forever to the right. So we would just do the typical thing of x is part of the set of all real numbers. And then the range, and we can see that it's a minimum, so it goes up from there. So we would say that y has to be equal or greater than our negative 30.25, and y is also part of the real values. So if we look back, all of this agrees with what we did in our first method of doing it. That is completing the squares, and we can show the graph. These other methods, they are bringing up skills that you've learned before, and they all make total sense and kind of avoids working with the decimals to some degree, not totally. But anyways, two ways of doing that.